Now we have to prove that this formula is a logical law, and we are supposed to use the resolution algorithm for that. So how can the resolution algorithm prove a formula being logical law? Well, it cannot. I mean, by default, it can only prove a formula being unsatisfiable. That is, in this case, we have to actually prove the opposite, exactly the opposite. This means that basically we should negate this formula. If we could prove that the negation of this formula was unsatisfiable and set, then it would mean that this formula would be a logical law. Okay, so let's do it. Let's do this. Let's negate this formula first. So we take the negation of this formula, and then we have to convert it to CNF. So let's do it. Since the entire formula is negated, we can, at the beginning, use the De Morgan laws first of all. So basically, we should negate all of the operands of the main disjunction, and that disjunction turns into conjunction. Here we have a negation already, so this negation disappears, fortunately. We don't have to touch this part. And finally, we have to negate the very last operand of the original disjunction. Okay, so immediately we can erase this parenthesis, and here we are. Okay, so what's the next step? We can apply the De Morgan laws to this part of the formula. This one turns into H or E. Then let's eliminate this implication. Of course, this means that the first operand of this implication is negated, and immediately let's apply the De Morgan law to this part here. So this is going to be not H or not I. Then let's continue, and I, and here at the end we can see a negated implication. The best choice is to apply the law of contraposition here, which keeps the left-hand side not E, and makes the implication turn into a conjunction, and finally it negates the right-hand side. I think we are done. This is already in CNF, right? Yeah, this is already in CNF. So the next thing to do is to run the resolution algorithm. For this, let me just enumerate all the clauses we got inside the CNF. So first of all, we have a clause H or E. Then we have another one, not H or not I or we. And then we have 3 unit clauses. A unit clause is a clause which contains only one literal. The first unit clause is I. The second one is not E. The fifth one is not we. Okay, so we have 5 input clauses. And now let's execute the resolution algorithm over this clause set. There are plenty of ways to do that. Now I'm picking 2 clauses, let's say clauses 1 and 4 at the beginning, and I'm generating the 6th clause, which is H. Then I take this latest clause H, and of course I can choose clause number 2 for the next resolution step. So now the resolvent is not I or we. Then I can go on with this latest clause, and of course I can choose clause number 3 as the other clause, which creates the resolvent V, and we almost finished. We can pick clause number 5 and 8, V and not V, which generates the empty clause. So what does it mean? This means that this clause set here, this is unsatisfiable. And of course, this means that the negated formula here is also unsatisfiable. And it means, since this was the negation of the original formula, that the original formula is a logical law.